Hi, so today we're going to learn about families of functions, transformation, and symmetry, and this is under college algebra and / pre-cal because this comes up in pre-cal as well. Okay, so before I go over the problems, I'm going to go over some rules. I want to go over reflection, stretching, and shrinking. So one rule for the definition of reflection is y equals negative f of x is a reflection in the x-axis of the graph of y equals f of x. And then the definition of stretching and shrinking is the graph of y equals a times f of x is obtained from the graph of y equals f of x by stretching the graph y equals f of x by when a is greater than 1, or shrinking the graph of y equals f of x by a when a is greater than 0 but less than 1. Okay, so that all this means is when you have the function like square root of 3 square root of x, it's being stretched by a factor of 3, right? So pretend this is the graph of, this is y equals square root of x, right? This is what a typical square root of x looks like. But when this graph is being stretched by 3, so that's what when it means stretched. Now, parabolas and absolute values are a little different. They're actually the opposite. Like, let's say you have this. Okay, so you have y equals 1/2 times absolute value of x. So remember the absolute value graph looks something like this. This is your typical y equals absolute value, right? Now this 1/2 means it's actually being stretched by a factor of 2, so it would look something like this. Is just a rough estimate. It's basically being stretched by a factor of 2. And this rule applies to the like parabolas, and well, I'll go over the problems more. So and then the even and odd function is really simple. So like basically, if it's an even function, if you put a negative x, and if you plug in a negative number and you get a positive and the outcome becomes positive, it's an even function, and it's symmetric on the y-axis. And another way is just I'll teach you another way how to figure out if it's even or odd. You could look at the degree, and I'll go over the problems. And then the odd is symmetric about the origin. So if you put a negative inside, if you put a negative function and your outcome becomes negative, then it's an odd, and it's symmetric about the origin. Okay, so let's actually do the problems to actually understand these definitions. So okay, so the problem says sketch the graph of each pair of functions on the same coordinates. So we're going to graph these two functions. F of x equals absolute value of x, and then g of x equals absolute value of, and then this is not inside the absolute value, so it's -4. So look at these two graphs. I know from the second graph there's a translation, right? There's a translation. Translation downward. Of -4. Right? So let's graph it. Try to make it kind of nice. Okay, so let's graph this absolute value of x. So the absolute value of x just looks something like this. Now, if you want it to be more specific, notice there is an invisible. Do you agree that there's an invisible one right here, right? That's really our slope, so it's like rise over run. So you start at the origin of 0, right? And then you could go up 1, right 1 here, and then you could put this point right there, up 1, right 1 there, up 1, right 1 there, up right, etc. And the same with the left. So I would go up 1, left 1, up 1, left 1. If that's it, if you wanted to make it look more like precise. But I'm just giving you a rough estimate. Okay. Now let's do g of this is f of x equals absolute value x. It's very important to label the graph. Okay, and then the g of x is absolute value of x minus 4. So I said there's a translation downwards on the y-axis. So here's the y-axis. We're going to go downward. Instead of the origin of 0, 0, we're going to go downwards. First, this will be our new origin. So it would be 0, 1, 2, here's negative 4. So our origin is 0, negative 4, or our y-intercept is that. And then it's going to just make that V shape, like, oops, sorry. See, notice that there's no stretching, there's no compression. It's only there's only a translation. Now, translation can either go downwards on the y-axis or upwards on the y-axis. It can also go rightwards on the x-axis and then leftwards on the x-axis. And we'll go over more problems, and I'll show you what we mean. So yeah, that's how you graph both of them. That one. So let me do another one. Okay, so this one says we have y equals x squared, and then y equals x minus 3 squared. Okay, we know how this one looks like. It's a simple parabola, like that simple U shape. This one is a parabola. It's also a quadratic, and it's also a polynomial. But we know that this is a little bit, there's a translation. But it's not on the y-axis, it's on the x-axis. And it's not negative 3, it's actually positive 3. So there's a translation of 3 units to the right. Well, you're probably thinking, why not 3 units to the left, right? Well, it's actually always the opposite, and if you ever get confused, what you can do is you can look at the inside of the x minus 3 and you can set that to 0. So I add 3. So we know that it's 3 units to the right because it's positive. So yeah, it's always the opposite. So let's start graphing it. And I'm just giving it a rough estimate. If you wanted to make it like really nice and pretty, you can use make a chart. But yeah, I'm just making it. Okay, let's graph the parabola. So y equals x squared looks something like this. There is no reflection. There is no translation, and there's no translation. Now let's graph y equals x minus 3 squared is a parabola, but we're moving 3 units to the right. So instead of 0, 0 at the original origin, we're going to move 3 units right, 3 units to the right. So it's 1, 2, 3. And then what you do is make that same parabola. Oops. So this is y equals. And yes, this is actually a quadratic and it's a polynomial. And I actually will do a section on that, on quadratics. Okay, let's do another one. So we have y equals square root of x, and then y equals square root of x plus 9. Do you guys remember the graph of a square root? A typical square rooted graph looks something like this, right? It starts at the origin 0, 0, and then it just goes like this. This is a typical square root of x graph. Okay, now let's look at the other graph. There is a what can you tell me? Is there a reflection, translation? There's definitely translation. But how much units? It's going to be translation 9 units to the left, not right. So you're going negative 9 units, right? The reason how I got negative 9 is it's what I did was it's always how many units does it make it to 0? Or what you can do is do x plus 9 equals 0 and then solve for x if you ever get confused. So x equals negative 9. So you're moving negative 9 units to the left, right? 9 units or 9 units to the left. So let's graph those two. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is negative 9. Label your axis. So let's graph the square root of x. So the square root of x looks something like this. It starts at 0 and then it just gradually goes up. So this is y equals square root of x. Now let's graph y equals square root of x plus 9. We said there's a translation of 9 units to the left, so instead of 0, we're going to go to negative 9, so it's right 9 units to the left, so it's right here, and then do the same, and then draw the square root graph, which is something like this. Right? So this is y equals square root of x plus 9. Good. So let's do this one. F of x equals square root of x, and then g of x is negative square root of x. Okay, so let's look at these carefully. So we know what is square root of x because we just did one. Now this one has a negative outside this outside the radical, right? So this is what's called, whenever it's outside the radical, it's this is not a translation, but instead it's called a reflection. Reflection, and it's reflection on x-axis. Okay, so let's okay, so we have the x and the y. Yeah, these are just rough estimates. You just need to know the important concept, like reflection and translation. Okay, so so this is your typical y equals square root of x. There's no translation or reflection because there's no number or negative. Now let's look at the, okay, here's our x-axis and here's your y-axis. When we say it's a reflection on the x-axis, it's this, but flipped, but on the x-axis. So it's going to look something like this. So this is your typical negative square root of x graph. Okay, so here's the x-axis and it's flipped. How you can remember it is like, you could think of it as not folding the paper in half, but folding it like a taco, if that makes sense. You have a reflection on that. That means if you're folding the paper like a taco, then there's a reflection on the axis. If you're folding the paper like a book, then there's a reflection on the y-axis. Okay. What about this one? Y equals square root of x. Y equals 3 square root of x. Look at it carefully. So we know this one. Now this one looks weird. There's no negative. It's a positive 3. So our a is 3. So what does it mean? It means it's being stretched. By a factor of 3. It's not being shrinked, and let me show you. It's not a parabola. It's not an absolute value or a parabola. It's a square root. So that means we have to this means it's going to be stretched by a factor of 3. If it was like 1/2, it would be shrinked by 1/2. So let's do this. Oh, not straight. Now, if you want, you can actually make a table for this one, right? If you wanted to make it really nice, not like mine. So this is your y equals square root of x. So if it's being stretched by a factor of 3, it's going to look roughly like this. For this part, you can actually make a table to figure out what it really looks like. So let's say you did make a table for that one. So what number I will use I'll just use positive 1 and positive 2. So actually I'll use 0, 1, 2, and 3. So 0, 0, 0, right? If you plug in 1, square root of 1 is 1 times 3, which is 3. And then 2 would be about 4.24. And then 3 is 5.1. So what you could do is just just graph those points. So here's 0, 0, 1 and 3, 2 and 4.2, and 3 and 5.1, etc. But it's basically going to look something like this. It's going to be stretched by a factor of 3. What about this one? Y equals x squared and y equals 1/4 x squared. Okay, so let's look at, we have a parabola, and then this one is 1/4, but remember what I said about the rule for that one? If it's a parabola or an absolute value, it's the opposite of the rule for the square root and the linear equation. So for this one, it's actually being, it's not being shrinked, it's actually being stretched by a factor of 4, right? Because how I got 4 was I did 1/4 of x squared equals 0. No, that's not right. It's 4 because we needed to get 1, so 4 times 1/4 is 1. That's how I got 4. So basically, it's going to look something like this. So I think stretched or compressed. Stretched and compressed are the same thing, right? No, it's not. It's just being stretched, not compressed. There's a difference. For the second one, we might have to use a chart to make it really to give it more specific points. So this is your typical y equals x squared, and then since it's being stretched, it's the y equals 1/4 x squared is going to be stretched, so it's going to look something like this, roughly. And when I say roughly, this means you have to actually put a table. So this is y equals 1/4 x squared, and then you could just make a table. So what I will use 1, 2, -1, and +2. I'm just going to use 4 points. So if you plug in 1, you get 0.25. If you plug in 2, you get 1. If you plug in -1, you get is positive 0.25. And if you plug in 2, you get positive 1. So if you were to plot it, so here's 1, and then you go up 0.25, and then go 2 right, and then up 1. And then here you go -1, you go up 0, 1.2, and the same thing with 2, 2, 1. You can actually add more points. You could actually add it to 0, right? That would be 0, 0. And that's true because it's still the origin. So if it's actually a fraction, if it's a fraction, and if it's the parabola or an absolute value, it's always the opposite. So 1/4, you may think of 1/4 as it's getting smaller, but it's actually being, you may think 1/4 is actually shrinking it, but it's actually being stretched by a factor 4. And this only applies for absolute value and parabolas, and because since a parabola is a quadratic, so it's actually it's just a little different form. It's different from the square root graph and the linear equation graph. So let me clarify. So if it's, remember, if it's the square root graph, and if it's 3, that means it's actually being stretched. So right, it's being stretched by a factor 3. Now, if it was a parabola or an absolute value like y equals 3x squared, this means it's actually being shrinked by 1/3. So here's your typical y equals x squared graph. Now that it's actually being shrunk, so it's going to look something like this. And this same rule applies for absolute value. And then I guess we should do more so you can understand. So we have y equals x squared, and then y equals 1/4. Oh wait, I did that one, sorry. Oh, new one. So we have y equals negative square root 4 minus x squared. Okay, so I'm looking at this graph, and I know it's a semicircle. If you don't know, please review your circles and your semicircles graph. So I know this is a semicircle. And it has a radius, not 4, but 2. So, yes. So it will look something like this. Okay, so we said we're going to graph this part. We said it's a semicircle, and it has a radius of 2, and it starts at the point of 0. So here's 0, and it has a radius of 2, so we're going to go right 2 units, 1, 2. 2 units left from the origin, so 1, 2. And 2 units upwards from the origin, so 1, 2. So it should look something like this. Okay, now let's look at the second graph. This looks exactly like this, but instead there's a negative. What do we know about negatives? If there's a negative in front of the radical, we know it's a reflection on x-axis. So remember when I said reflection on x-axis, it's like folding the paper like a taco. So here's this graph. Now we got to fold it like a taco, so it's, and if you do that, it'll look something like this. Right? Yes, it will look something like this. Yeah, so the only difference is there was a reflection on the x-axis. Now let's graph this one. We're not going to graph two, it's just one graph now. So we have y equals x minus 1 square plus 2. So we got to graph this. Okay, so tell me, is there a translation? Any translation? Yes, there is a translation. There's going to be a translation on the x-axis and on the y-axis. Translation. And then, so translation on x-axis, it's going to be 1 unit to the right. Right? Because look here, we have an x minus 1. X minus 1. If you set that to 0, you add 1. So you're moving 1 unit to the positive right. So we have 1 unit. Okay, now we have a translation. Translation on y-axis. See how now for y-axis it's really different. It's not the opposite. You know. Okay, so remember how it's always the opposite of this one. We thought it's going to be, instead of a -1, it's going to be positive 1. But for the reflection on the y-axis, it's always that, it's just that exact number. So if this is a +2, it's going to be 2 units to the upwards, right? On the y-axis. So translation on the y-axis, so it would be 2 units upwards, or on the y-axis. So 2 units up. So we're going to move 1 unit to the right and 2 units upwards. And since this is I haven't gone over quadratic section, but note there's actually a vertex. And the vertex is the x and y value. So we know that it's 1 unit to the right on the x-axis, and then 2 units upwards on the y-axis, right? So it will look something like this. Okay, so we said we go 1 unit to the right on the x-axis, so that's 1, and then 2 units upwards on the y-axis, so that'd be 1, 2. So this is our vertex, and then we know it's a parabola, so it's going to make that U shape. So this is the graph of y equals x minus 1 square plus 2. What happened if it was a -2? If it was a -2, you would have to go, instead of 2 units upwards, we would go 2 units downwards. What about this one? Y equals absolute value of x minus 1 plus 3. Okay, so let's look. There's no negative numbers, or there's no number, except there is a 1, invisible 1 right here. But other than that, there's no negative, so there's no reflection. We have a shift of 3 units upwards, or we could call that vertical shift. And then we have a translation of 1 unit to the right. So remember, absolute graph looks something like this. It's like that V shape. So we said that it's translation 1 unit to the right, and then 3 units upward. This is the y-axis, and then this is the x-axis. And then we have or we could call that the vertex of 1, 3. Call this the x and y. Okay, so let's see. We said it translates to 1 unit to the right, or the x-axis. So here's 1. And then we said 3 units upwards on the y-axis. So here's 1, 2, 3. And that is our vertex. And then we have to make that V shape because it's an absolute value graph. So it will look something like this. And if you wanted to make it really specific, you can plot points and do the table if you wanted to make it look really good. But I just made a rough estimate. What about this one? We're doing a linear equation, so y equals 3x minus 4. 3x minus 4. So this is a linear equation, and from linear equation, we know that mx plus b, so b is our y-intercept, and m is our slope. So what would be our y-intercept rate? Our y-intercept would be negative 40. So it would be 0, negative 40. And then our slope is 3. What you can do is you could start at your y-intercept. Here's negative 40. And then we said that our slope is 3, or 3 over 1. And when it's positive, so it's going to go this way. So what you can do is, I don't really want to do this way because it's going to take too long. What you can do is, from negative 40, you could go up 3, 1, 2, 3, 1 right? And it should look something, this is such a bad, but this is how you, that's one way you could go. So you start at the y-intercept and then you rise over run. Or if you are really lazy, you just really need, all you need is 2 points to graph a point. So we know 1 point, which is our y-intercept, is 0, negative 40, and other point is we need the x-intercept. we find the x-intercept by plugging 0 into y, so wherever there's a y you plug in 0, so it would be 0 equals 3x minus 40. Add 40 both sides, so you get 3x equals 40. Then you divide by 3, and then you should get x equals 13.3. So our x-intercept is 13.3, 0. And that's all you need to know. I mean, you just plot those 2 points and connect the dots. So here's negative 40. This is just roughly negative 40. I'm not. And then 13.3 should be right around here. This is not in scale, by the way. And we know it's positive. So it should look something like this. So yeah, that's how you graph a linear equation. Okay, what about this one? Y equals negative 1/2 x plus 4. So remember, this is a an absolute value graph. So it's always the opposite. So this may look like it's shrinking, but it's actually being stretched by a factor of 2. Okay, so let's look at the translation. We're going to translate of 4 units to the left, right? Because it's the x plus 4, and what I did was I did the x plus 4 and I set that to 0, and then I subtract 4, and then you get x equals negative 4, right? So we're moving 4 units to the left. That's why we have translation 4 units to the left. Now, there's a negative right here. So what do we know about negatives? There's a reflection on x-axis. And then we also know this 1/2, it's going to be stretched by a factor of 2. Since this is more complicated, I'm not going to actually draw it all at once. I'm going to draw it little by little, because if I draw it all at once, I will make a mistake. So let me graph the absolute value of negative 4. 2, 3, 4. Okay, here's negative 4. And then the absolute value will look something like this. So this is y equals absolute value x plus 4. Okay, now we said there's a negative, so there's going to be a flexion on the x-axis. So it will look like this. So this is y equals negative x plus 4. Okay, so this 1/2 means it's being stretched by a factor of 2. So for this one, you can actually, I will make this more. One, 2, 3, 4. label your axis. Okay, so we said here's -4. 1, 2, 3, 4. So we said it's being stretched, so it's going to look a little bit wider than this one. So what you can do is you can you could actually go down 1 from -4, down 1, and then right 2 units right. 1, 2. So here I did, here's -4, and then I'm going down 1. You could think of -4 as our vertex. And then you go down 1, right 2, 1, 2. So this is what it looks like on that side. So here, and then we could go down 1, left 2, 1, 2. Down 1, 1, 2. So it should be this point. So it's being stretched by a factor of 2. So this is your y equals -1/2 x plus 4. And I didn't do it all at once because I knew I could make a mistake. I just did it little by little. So what I did was, after I got this point, I started from the origin, the vertex, -4, and then I just go down 1, right 2, and then down 1, left 2. And that's how I got these 2 points. Okay. We got y equals -square-root x minus 3 plus 1. Plus 1 is not inside. So this is a square root, right? A square root graph. So it's not the absolute value or the the parabola. So what do we know? So we know there's a translation. So there's 3 for the translation. We're going to 3 units to the right, because remember I got x minus 3, and I set that to 0, and then I add 3. So that's how I know that I'm moving 3 units to the right. And then we're going to move one unit upwards, right? This is on the y-axis. So this is what's called a vertical shift. Yeah, not a horizontal. Yeah, vertical shift of 1 units. So we're going to move 1 unit upwards on the y-axis, and then we're going to move 3 units to the right on the x-axis. And then this negative means we're going to have a reflection on x-axis. So I think I could just do it all at once for this graph because this one's not too hard. And then what is our vertex? Our vertex is the x value, which is 3, and then a y value, which is 1. So vertex is 3, 1. So here's 3, here's 1. Oops. So, and then we know remember square root graph looks like this weird, like this. So this is basically y equals square root x minus 3 plus 1. But since there's a negative, we're going to have to do some reflection on the x-axis, so it's going to look something like this. Yes, this is your final product. This is y equals x minus 3 plus 1. Okay, now we're gonna do odd and even functions. I think I've done that before. Use transformation. Yeah, we just done that one. So now it says determine algebraically whether the function is even, odd, or neither. Discuss symmetry of each function. So let's go back to the rules. So basically, if you plug in a negative function and you get a positive outcome, it's an even function and it's symmetric on the y-axis. So I know, let's graph y equals x fourth. Y to the x fourth kind of looks like x squared, but it's a little bit wider, right? So this is approximately what x to the fourth looks like. So this is what y equals x to the fourth. Now, remember when I said we said that it's there's going to be it's symmetric on the y-axis. This is definitely an even function because when you plug in f of negative x, if you plug in negative into the function, you still get positive x fourth, right? So that's how I know it's even. And it's symmetric on y-axis because if you fold it like a taco, you're going to get something like this. That's why it's you fold it like a taco, you get a reflection on the y-axis. If you fold it like a book, you get a reflection on the x-axis. And then the other way is like you can just look at the degree. If all the degrees are even, then it's even. If all the degrees are odd, it's odd. If you get an even and odd, that means it's neither. So let's do another one. So let's say you got f of x equals x to the fourth minus x to 3. So remember the rule, it just look at the degrees. If you have, so we have 4 is an even, right? And then 3 is an odd. If you have an even, if it's not like constant, like if it's not even or odd, it's neither, because like we have an even and odd, so they don't match up, so it's just neither. So there's no symmetry. There's no symmetry, and it's why it's no symmetry because this is quadratic or this is a polynomial. So polynomials are really weird, right? Polynomials graph, they could go right. This is a typical polynomial. There's no reflection because of this. It wouldn't come out evenly. So that's why it's even and there's no symmetry. What about this one? So what I'm going to do is I will FOIL it. So I get x squared plus 6x plus 9. Now let's look at the degrees. We have a 2, so that's even. We have a 1, that's odd. And then when you have a number by itself, you have a 0 degree, right? Because you could think of it as 9 times x to the 0, right? Because anything to the 0 is 1, so 1 times 9 is 9. So 0 is actually an even. But so it doesn't match up. You have even, odd, even. So it's definitely neither. Right? If you were to graph it, it's a parabola, but there's translation 3 units to the left. Whoops, sorry. Should look something like this. So it would roughly look like this. And if you fold it like book-wise or taco-wise, there won't be any reflection, right? If it was just a regular parabola, there is a reflection on the y-axis, right? But there's a shift. There's a translation of 3 units to the left, so that's why it's neither. What about this one? I don't even know how, like, the degree, so what I could do is I'm just gonna graph it. Okay, so it's a absolute value, but there's a translation of 2 units to the right. So here's 1, 2. It's gonna look something like this, roughly. Right? If you fold it in half or a taco-wise, there still won't be any reflection. It would be a reflection if it was just regular absolute value of x, because absolute value of x looks something like this. And that is probably your next problem. So this one is neither. And then yeah, like the last problem, I said f of x equals so let's say we have f of x1, right? We know 1 is an odd, and if you plug in negative into the function, you get negative x. So it's an odd function because if you put a negative, it's an odd, and so that means it's symmetric on the origin. It's odd and it's symmetric about origin. So let me graph it. We know that this is just a regular linear equation with no y-intercept, so it's going to look something like this. It's going to start at 0 because it has no y-intercept, and it's just going to go up 1, rise 1, up 1, rise 1. So eventually it will look like this. So this is y equals x. And then y equals negative x is exactly the same, but it's going to look opposite like this. So this is y equals negative x. Notice how they both pass through the point of the origin. So that's why it's symmetric about the origin, because they both pass through the point of 0, 0, right? Let's do 2 more. Okay, so we have 3x plus 2. let's look at the degrees first. This one has a 1, and then this one has a 0, right? So we know 1 is odd, and 0 is even. So they don't match up, so it's just neither. And then if the other way is you put a negative into the function. So 3 times negative, it would be negative 3 plus 2. Negative 3x plus 2. No, it would be negative 3 plus 2, which is negative 1. So yeah, sometimes this doesn't really work. If you ever get confused, just look at the degrees, like I did. So we know this is 1 and 0, so it's odd and even and neither, and you just have to graph it. You can graph it if you want to. So this is a linear equation with a y-intercept of 2, so it'd be 1, 2. And then you go up 3, 1, 2, 3, and 1 right. So it will roughly look something like this. If you fold it in half or in taco, there will be no reflection. If it was right here, there could have been a reflection, right? It would be reflection on the origin, but it's not, so it's still neither. Final one, last one. So what if we have f of x equals x cubed minus 5x plus 1? 1, yeah. So we can look at the degrees. So this is a 1 and then this is a 0. So 3 is odd, 1 is odd, 0 is even. It doesn't add up, right? Because it's odd, odd, even. It should be even, 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 or odd, odd, odd. So it's going to be neither. And I know this is a polynomial, and polynomials are weird. Like, they could go something like this. So there's no reflection whatsoever, so it's just neither. And that's it for the section.